Okay, in our next lesson here, what we're going to be doing is continuing our discussion of Newton's laws of motion, and today we're going to focus on the second law of motion. Newton's second law of motion describes how force, mass, and acceleration are connected. It states that the acceleration of an object is equal to the net force divided by its mass. So in other words, acceleration equals force divided by mass. Now we can change this as well, again, just like we have done before. Okay. A lot of times we will see this written as F equals ma. You can also draw the triangle where you have F on top, you have A, and you have M. Alright, so it's very much like the density triangle and the one that I showed you for speed as well. Okay, so like I said, it can also be written as F equals ma. And basically what this means is if the object is not accelerating by slowing down or speeding up, then we have no net force acting on it. Because if we have my acceleration equal to 0, then this whole side is equal to 0, so therefore the force is equal to 0. What we have to keep in mind based on what we learned about force is that the acceleration is always going to be in the same direction as the net force. When the net force is in the opposite direction of motion, it produces deceleration and reduces speed. So for example, the seat belts, they actually provide force in the opposite direction of motion when you are in a car, so that you decelerate, you slow yourself down, because remember, inertia is telling you to keep going forward, seat belts slow you down. The units for acceleration are equal. So in other words, if I take a Newton, my force, and divide it by my mass in kilograms, I get the units of meters per second squared. So a Newton divided by a kilogram is the same thing as meters per second squared. So the only really tricky part about this is you do have to make sure that your masses are in kilograms. All right, so let's look at a second law problem here. An automobile with a mass of 1,000 kilograms accelerates when the traffic light turns green. If the net force on the car is 4,000 newtons, what is the car's acceleration? Okay. All right, so what I'm going to do is I'm going to go to my blank screen here, and I am going to solve this problem. Okay, so we know we have force and mass and acceleration. So just like before, I'm going to list these three things out. Okay, so my force is 4,000 newtons. The mass of the car is 1,000 kilograms. And again, just double check to make sure that that's in kilograms. And the acceleration is what we are looking for. Now, we start with this F equals ma, but remember, if we have our triangle, we can change it. So F, M, A. If I'm solving for A, then I take the force and divide it by the mass. Okay, so my A is going to be my force, which is 4,000 newtons, divided by 1,000 newtons, or 1,000 kilograms. So my acceleration is going to be 4. Now it has to have a unit, but because I have newtons divided by kilograms, I just write meters per second squared, and I am all done. 4 has 1 sig fig, so my sig figs are also correct on this. All right, let's take a look at the next one that you have. A boy pushes forward a cart of groceries with a total mass of 40 kilograms. What is the acceleration of the cart if the net force is 60 newtons? So, again, force, mass, acceleration. The force on the cart is 60 newtons. The mass of the cart is 40 kilograms. And what I am looking for is the acceleration. So, if I set that up to solve for acceleration, I'm going to take my force, which is 60, and I'm going to divide that by 40. Double check. This is in kilograms, this is in newtons, so I am good in terms of my units. Now my acceleration, when I plug this into my calculator, I get a 1.5. However, if I look at my measurements, each of them have 3 sig figs, so this has to have a third sig fig with a 0 on the end, and my unit is meters per second squared. Let's try another one. Next one. What is the upward acceleration of a helicopter with a mass of 5,000 kilograms if a force of 10,000 newtons acts on it in an upward direction? So my force is 10,000 newtons. My mass is 5,000 kilograms. And my acceleration is what I am looking for. So acceleration is my 10,000 divided by my 5,000. When I plug that into my calculator, I get 2. And that's the right number of sig figs. Double check, I have newtons and I have kilograms, so this has to be meters per second squared. Now, those two we solved for acceleration, but we can also solve for any of the things. We can actually solve for both mass or force. So let's take a look at this one. The automobile has a mass of 1,200 kilograms and it accelerates at a rate of 3 meters per second squared in the forward direction. What is the net force acting on the automobile? So I am trying to figure out the force. My mass is 1,200 kilograms and my acceleration is 3.0 meters over second squared. So if I look at the triangle, if I'm solving for force, I take my mass and multiply it by the acceleration. Okay, so I take 1,200 and I multiply it by 3.0. So my force is going to be 3,600 on my calculator. Now because I'm dealing with kilograms and my acceleration is meters per second square, this unit will be newtons. Now if we double check sig figs, okay, we have 2 sig figs here and 2 sig figs here, so I am actually okay with that one because my answer has 2. Alright, one more here. Alright, a 25 Newton force accelerates a boy in a wheelchair at half a meter per second squared. So that's his acceleration. What is the mass of the boy in the wheelchair? So we have force, and it's 25 newtons. The mass is what we're solving for. And the acceleration is 0.5 meters per second squared. Okay, so this time we're solving for mass. So if we think of our triangle again, we have F, M, A. So now I'm going to take my force and divide it by the acceleration. So mass equals 25 divided by 0.5. So my mass is going to be 12.5. The unit would be kilograms. Now let's take a look here at, oh, not 12.5, I'm sorry, it's 50 kilograms. Now let's take a look at the sig figs. 25 has 2 sig figs, but my 0.5 only has 1. My answer 50, as I have it written, also only has 1. So my final answer is 50 kilograms. Now, for this section, I actually have 2 worksheets. The one with the title at the top that says Force and Acceleration that has 5 problems on it is a practice sheet that you can work on. The Newton's Law homework one is the one that actually you will need to turn in as homework. All right, so you can work on the force and acceleration one and check your answers, and then the Newton's Law homework, you can solve those 10 problems and then turn that in for homework.